Hello, in this video we will be calculating r, which represents hypotenuse for a reference triangle for any angle through a given point xy. In this example we are given a point -3, 5 that is on a reference angle. We have to construct a reference right triangle and calculate hypotenuse using Pythagorean theorem. So let's draw x and y axes. -3, 5 means x is negative, y is positive. It will be in the second quadrant. It's around here. To draw a reference triangle, we need to connect it with the origin. The reference angle is always with the x-axis, so we have theta over here. And we need to drop a perpendicular to the x-axis. This creates a reference right triangle for this obtuse angle. So we are given that point is -3, 5. -3 represents the adjacent side to the theta. 5 is the y value, which is the height, the opposite side to theta, so 5 is here. And we need to calculate r. Pythagorean theorem is c squared equals to a squared plus b squared. A and B are legs of the triangle and C is the hypotenuse across from the right angle. So we're going to take C, A and B and replace them with the values we are given. So hypotenuse in this right triangle is labeled with r, so we have r squared equals to one leg of this right triangle is -3 squared plus the other leg of this right triangle is 5 squared. R times itself will give us r squared equals to -3 times -3, we get a 9, plus 5 times 5, we get a 25, and now we have r squared equals to 9 plus 25, we get a 34. In order to solve for r, we need to do the inverse of the operation on it. The inverse of raising r to the second power is to take a square root. Since this is an equation, we have to do the same thing to both sides. So radical on the second side, square and a square root cancel, and we get r is equal to square root of 34. And this is our solution. In this example, we are given a point -4, -3 that is on a circle centered at the origin. We have to calculate the radius using the formula of a circle, which is x squared plus y squared equals to r squared. I want to point out that this is the circle with the center at the origin, which means it's at 0, 0. All we have to do here is substitute and solve for r. So what do we have here in this point? -4 represents the x value, so x is -4. -3 represents the y value, so y is equal to -3. Now all we have to do is substitute and solve. Instead of x, we will plug in -4 to the second, plus instead of y, we will plug in -3 to the second, and it's equal to r squared. -4 to the second is -4 times -4, which is +16, plus -3 to the second is -3 times -3, which gives us +9, equals to r to the second. 16 plus 9 is 25, equals to r to the second. In order to solve for r, we need to do the inverse operation of squaring, and the inverse of squaring is square root. Whatever we do to one side of the equation, we need to do the same thing to the other side, and we get square and the square root will cancel, which will give us r equals to square root of 25 is 5, and this will be our solution. In this example, we are given a point 2, -7, and we have to calculate r, the distance between the point and the origin, using the distance formula, which is d equals to square root of x2 minus x1 squared plus y2 minus y1 squared. Before we begin, we need to know what the second point is, and it's at the origin. So let's say point 1 will be the origin, and the origin is at 0, 0. This will make x1 value equals to 0 and y1 value also equal to 0. And let's have the second point P2 be the given point, which is 2, negative 7. And so this will give us x2 is equal to 2, y2 is equal to negative 7. Let's substitute and solve for r. The distance d will be replaced with letter r equals to square root. We have to take difference between x values and square it, and add difference between y values and also square that. So let's substitute x's. We have x2 is equal to 2 minus x1 is equal to 0. Let's substitute the y values. y2 is negative 7 minus 0. On the next step, let's simplify inside of the parentheses, and we get r is equal to square root 2 minus 0 is equal to 2 to the second plus negative 7 minus 0 gives us negative 7 to the second. Okay, so now we have r is equal to square root 2 to the second. We have a 4 plus negative 7 times negative 7, positive 49. So r is equal to square root of 4 plus 49. We have 53. And r is equal to 53 will be our solution. Let's summarize. We just saw 3 different ways of finding the hypotenuse of any angle. First one was the Pythagorean theorem, which is c squared equals to a squared plus b squared. Then we saw a formula of a circle centered at the origin, x squared plus y squared equals to r squared. And lastly, we saw difference formula, which is d equals to radical of difference between x2 and x1 squared plus difference between y2 minus y1, and it's squared as well. I just want to point out that if you're given point x, y, and you need to calculate r, the circle centered at the origin is the perfect formula to use, because once you substitute x and y values into this formula, all you will have to do is take radical of both sides and have r equal to radical of x squared plus y squared, and that would be the most efficient formula. That's all.